Task 5.4. Implement and manage authorization mechanisms. And as you notice from the other slides, there's a lot of security concepts overlap, and it's not by accident. Security is a holistic system, so the more you see these concepts over and over again, the more they reinforce your understanding of security and the exam. And remember, if I don't go as deep as you had hoped, that's what our LLM prompt at the end is for. So dive in. Task 5.4 has 7 subtasks: role-based access control, rule-based access control, mandatory access control, discretionary access control, attribute-based access control, risk-based access control, and finally, access policy enforcement. These tasks and methods are interconnected, and you'll see them pop up, and it may seem repetitive, but remember, it helps you solidify your understanding. And keep in mind that the exam is likely to test your ability to differentiate between these models and how to apply them in real-world scenarios. So as we go through each subtask, think about how these mechanisms work together as part of a larger holistic security framework. 5.4.1. Role-based access control. This is one of the most commonly used access control models, and you'll likely encounter questions about it throughout the exam. Here are the key points: roles and permissions. In RBAC, users are assigned to specific roles within an organization or system. Each role comes with a set of permissions that dictates what actions a user can perform, and this makes management a lot simpler. Simplified management. By grouping users together with similar job functions, RBAC reduces complexity. If you need to grant or revoke access, you do it at the role level, not individually. Flexibility. As organizational needs change, new roles can be created or existing ones modified, giving RBAC the flexibility to evolve along with your organization. Least privilege. Most importantly, RBAC aligns with the principle of least privilege, which is key to the exam. This means that users are given the minimum necessary permissions to do their job, reducing the risk of unauthorized access, intentionally or accidentally. The exam will test your knowledge of how to apply RBAC in different contexts, so understanding its advantages, especially in simplifying management and reducing security risks, is essential. 5.4.2. Rule-based access control. Please remember that these various models can overlap, so you could use role in our previous section to be one of the rules. But overall, rule-based focuses on predefined rules or conditions to grant or deny access. And here's what you need to know for the exam. Conditional access. Access determined by a set of rules based on factors like identity, role, resource sensitivity, time of day, even location. This can be, or think of this as a system that asks, do you meet all the conditions for access? Dynamic access decisions. The system evaluates requests in real time, making it highly adaptable. This means access decisions can change based on context, another concept that shows up in various CISSP questions. Granular control. The model allows for fine-tuned control over access. You can set up rules for specific resources, user groups, locations, making it useful for environments where precise access control is needed. Adaptability. A major benefit is how easily rule-based systems can adapt to changes. If new rules are needed, they can be implemented without overhauling the entire system. The exam may test you on when to use rule-based access control versus other models. So it's important that you understand its strengths, mainly in scenarios requiring very granular, dynamic, adaptable control. As with other mechanisms, rule-based can work in conjunction with RBAC and ABAC. For instance, ABAC, absolutely for time and location, will help enhance this model. So they do work together. 5.4.3. Mandatory access control model. This model is very well known for its strict access controls and its use in government military systems, the Bell-LaPadula model. But that's not the only model that is label-based, as well as BEBA, which is also multi-level. Clark-Wilson is not multi-level, but it is multiple compartments. So here's what you need to know. All Mac models associate every object with a label and every user with a label. The object label in Bell LaPadula is a sensitivity label containing the top secret or whatever the sensitivity level, but it also contains a compartment which helps us implement need to know. The clearance levels allow the decision to be made for least privilege, but then you also assigned a category set that on your clearance, that your subject label, that allows you to identify what compartments that subject can read. Now the SC Linux, the only OS I know currently that is NIAP 15408 Common Criteria certified in the US, supports and comes out of the box in a lightweight targeted mode or Clark Wilson model. These labels don't have multiple levels, but you can still implement need to know. And as we know from Clark Wilson, I can also specify what programs are allowed to access this particular data, not just the user. Centralized control. All Mac implementations implement some form of centralized management, and that includes SC Linux. For the exam, it's important to understand the flexibility of Mac and its high security applications, whether it's the very strict multi-level Bell LaPadula or Biba or the very adaptable SC Linux targeted mode. Mac continues to play a key role in securing data access. 5.4.4 Discretionary access control. This is considered much more flexible than Mac, but it comes with its additional risks. Owner control. In the DAC model, the owner, that's the creator typically, whether a file, folder, or any other system component, has at their discretion the ability to determine who can access it and at what level of access they're granted. This gives the owner significant control over access management, and it means they would be responsible for enforcing security. Each object has an access control list. Right-click it, permissions. Right. This is where you can give permissions to users or groups, and at a very granular level. Flexibility. One of the advantages is the owner can tailor the permissions to specific users or groups, giving them as much or as little access as they need. However, this flexibility can lead to inconsistencies in other security policy issues. Yeah, potential for misuse. While it's flexible, it might be prone to accidental or intentional misuse. If resource owners are not diligent, permissions can be inconsistently applied, potentially leading to a number of security risks. Understanding DAC for this exam involves recognizing its strengths and weaknesses. It gives the user full control, and with that comes a lot of responsibility. 5.4.5 Attribute-based access control. Adding to the most flexible and dynamic access controls that we can have is attribute-based access control. It allows us to define access based on current conditions like time and location, or a number of attributes. Flexible access control. ABAC allows access decisions to be made based on a wide variety of attributes, such as user role, device type, location, and time of day. This flexibility makes it highly adaptable to complex organizational environments. Attributes. The core of ABAC is the use of attributes, and this could be related to the user, the role department, the resource, the environment, or even the type of action. Read, write, whatever. Access is granted based on evaluating all these attributes in combination with our other predefined rules or policies. Policies. ABAC operates on policies that define the relationships between attributes and permissions. For example, if a user in the HR department, and it's during business hours, they can access employee records. This gives the policy administrators granular control over when they're allowed to access it and other ways they can do that. Contextual access. One of ABAC's strengths is that it evaluates access requests in real time, considering the context of the request. This makes ABAC ideal for environments where the needs need to be justified dynamically based on changing factors such as user location or device type. And adaptability. ABAC is highly adaptable to changing security needs. As new requirements or attributes emerge, they can be added without overhauling the entire system, making ABAC well suited for dynamic environments. 5.4.6 Risk-based access control. Before we get started, I want to remind you that these things overlap. You could be doing a role-based access control as part of another set of attributes that are done with these certain rules, right? So, in a discretionary type of hybrid model. So we always want to look at risk, and here's how it kind of works. Risk assessment. In this model, access decisions are based in real-time evaluation of the risk associated with granting access to a specific user or system. This means that rather than using fixed rules, such as this IP is always allowed to get there, the system continuously evaluates the situation to determine the appropriate access level. Contextual factors. Several factors influence the risk assessment, including user behavior, device security, network location, and the sensitivity of data being accessed. For example, if a user is logging in from an unknown location or using an untrusted device, the system might restrict access to or require some additional authentication. Dynamic access. This model allows access levels to be dynamically adjusted based on the assessed risk. For instance, a low-risk situation might allow full access, whereas a higher risk situation might limit access or require multi-factor authentication. Adaptive security. Risk-based access control is adaptive to the evolving threat landscape. As risks change, the system continuously adjusts access controls to maintain appropriate level of security. And continuous monitoring. Often this model involves continuous monitoring of user activity and system behavior. If any anomalies or potential threats are detected, the system can adjust access levels in real time. For the exam, you'll need to understand that risk-based access control overlaps with other controls, but is especially useful in environments where security threats are constantly changing. Flexibility is key. 5.4.7 Access policy enforcement is a critical part of ensuring that access controls that we've discussed are actually implemented and followed. Here's what you need to focus on for the exam. The policy decision point. The policy decision point is responsible for evaluating access requests against the established set of criteria. When a user tries to access a resource, the policy decision point determines whether that request should be granted based on defined policies. This is a security kernel component, right? So remember from our reference monitor is the set of rules of what should happen. This is when does the security kernel actually make its decision. Policy enforcement point. Once the PDP has made its decision, the policy enforcement point comes into play. It enforces the authorization decisions by intercepting access requests, sending them to the PDP, and then either allowing or denying access based on the PDP's response. Essentially, the PDP is the gatekeeper that ensures policies are followed. Centralized policy management. Access policies are usually managed centrally, which allows for consistency across the organization. The centralization also simplifies updating policies where changes are made in one place and they apply to the entire system. Real-time enforcement. Access policy enforcement happens in real time or near real time. As soon as a request is made, the system evaluates it against the current policies and contextual information. It ensures that access decisions are always based on the latest policies and environmental conditions. Auditing and logging. One important part of policy enforcement is the logging of access requests and decisions. These logs provide a valuable trail for auditing and incident response, helping organizations ensure that access policies are being applied correctly and any violations are identified. For the exam, it's crucial to understand how the PDP and the PEP work together to enforce access policies, and how real-time enforcement and auditing contribute to the overall security. This is where the theoretical side of access control meets the real-world application, and it's essential that you grasp how enforcement mechanisms keep everything secure. All right, summarizing and our next steps here. All right, so what big takeaways here on task 5.4, implementing and managing authorization mechanisms. One, understand the models. Role-based, rule-based, mandatory, discretionary, attribute-based, risk-based models. And again, there's overlap. There's not, you don't just pick one, right? Principle of least privilege. The principle is the same theme across all our other models, right? Don't give people more rights than they need. And again, that's a hierarchical thing. But also you say just because you needed whatever right access doesn't mean you need right access everywhere. So that's why we have compartments. And real-world application. The exam focuses not only on theory, but also on how to apply these models in real-world scenarios. Be prepared to answer a lot of scenario-based questions where you need to make decisions about which access control model fits a given situation, balancing security needs, usability, flexibility, and all that stuff. All right, let's take a look at our LLM prompt and see how we can improve. I hope you're really having fun. In fact, I actually hope by this point, at least 20% of you are going, oh, dude, I use that as a template, but you should see my exam prompt now. So play with it, add to it. This is just a template. At this time of my recording, I'm always messing with it too. In fact, I've had to change the entire thing a few times because I came up with something that I liked better. Enjoy. See you in 5